See, after conductance, next topic, electrolysis. See, one part is our in electrochemistry, conductance. Conductance, types of conductances. Okay, and we did some questions also, NEET level and some JEE questions also we did. Next concept, electrolysis. Already I given introduction about electrolysis. Electrolysis, electrolyte and signs, sign of cathode, anode. Which reaction takes place at anode? Oxidation. At cathode, reduction. So I given introduction about electrolysis and electrolytic cell. Once again I revise main terms, terminology. Electrolysis. Electrolysis is the process of decomposing a chemical substance by passing the current. Right? We take electrolytic solution in a beaker and we insert electrodes and we pass the current. At that time, chemical compound undergo dissociation or splitting. That is called as electrolysis. Right? Already this topic is over. Just I am revising. See, the device in which electrolysis is carried is called as electrolytic cell, where we conduct this electrolysis process in a device. That is called as electrolytic cell. This is electrolytic cell. This device contains electrolyte. Electrolyte is the compound which is going to be decomposed when we pass the current. It may be liquid, mostly pure liquid or solution. Okay. Fusion or molten means pure liquid. Without adding any water, we'll get the liquid by heating the salt. Solution means after dissolving salt in water, we'll get the solution. That is electrolyte. It is a liquid which is going to be decomposed by passing the current. We connect the electrodes. These are electrodes. Electrodes are metal plates. What is the purpose of electrodes? They act as entrance and exit for current. With the help of electrodes, we pass the current into the electrolytic solution. This is anode and this is cathode. Already we computed clearly. Sorry. Right. At anode always oxidation takes place. At cathode always reduction takes place. We did one example also. We did electrolysis of fused NaCl. Fused NaCl. Once again, let us revise electrolysis of fused NaCl. Electrolysis of fused NaCl. Fused means the liquid which is obtained by heating salt directly without adding water. Take salt in a bowl and heat it. It will melt. That melt is called as fusion state or molten state. Electrolysis of fused NaCl. Once is I am revising the previous class, right? Let us take sodium chloride, Cl negative ions and Na positive ion. Both are held together by ionic bond. How can we pass the current into the solution electrolytic liquid? With the help of electrodes. Connect these electrodes to battery. The electrode which is connected to positive terminal will get positive charge. The electrode which is connected to negative terminal will get a negative charge. This is called anode and that is cathode. When we pass the current, what happens? At anode. This is just a one shot revision only. If you want clear explanation, go through the videos, right? At anode, always which reaction takes place? At anode, always oxidation takes place. Oxidation means loss of electrons. See, at anode, first write anion. See the pronunciation, anode, anion. At anode, what you have to do? First write anion. At anode, anion. Take anion. Now, this chlorine is carrying electrons, right? Chlorine moves towards anode and gives its electrons to anode, electrode. Chlorine lost electrons, and that lost electron is represented like the C negative. But single chlorine is not possible, so we write a half Cl2. Or you can take here 2Cl minus Q space to Cl2 or 2 electrons, right? So chlorine gas is liberated. Chlorine gas is liberated at the anode. At cathode, at cathode, reduction takes place. At cathode, always reduction takes place. Reduction means addition of electron. See, sodium plus is moves towards cathode, oppositely charged electrode, negative charge. And there it will catch electron. Sodium plus will get electron and converted to sodium metal deposited, downward arrow, downward arrow. What is the source of this electron? How it is getting electron? See, chlorine is giving its electrons to anode and that electrons move in this direction. See, this is electron direction. All this explanation is over in the last class. Now this cathode is having electrons which are coming from anode. Now this surface is full of electrons. Sodium reaches this cathode and takes that electron and get reduced. So this is the last class. We completed up to this. What is the direction of movement of electrons? See this anode to cathode. Anode to cathode. At anode always oxidation takes place. At cathode always reduction takes place. We discussed up to this in the last class before conductance. Means under introduction I explained all the things, right? Okay. Let us start continuation. Next topic. See, when we take fused sodium chloride, fused NaCl, we have one sodium ion and one chloride ion. There is no problem, right? In fused NaCl, one sodium ion and one chloride ion will be present, right? If we take aqueous NaCl, in aqueous means salt solution, brine solution. Another name for salt solution is brine solution. If you take brine solution, sodium chloride solution, then we have more number of cations and anions. Then which ion will move towards a particular electrode? Ambiguity will arise. Let us see. Keep heading electrolysis of aqueous solutions. Next topic. Today's new topic. Electrolysis of aqueous solutions. Online students. Hello. Ketra. Aisha. Aisha. నాకు ఫోన్లు ఎక్కువైతున్నాయి బాగా శ్వేత ఒకసారి చెప్పు సార్ చెప్తారని చెప్పు మళ్ళీ నేనంటే ఫీల్ అవుతుంది రిటర్న్లతో నువ్వే చెప్పాలి ఒక వార్నింగ్ లాగా అన్నమాట Just take, I'm taking attendance. 14 members attendance. Ayesha, Julia, Kirti, Ketara, Lochana, Pragnika, Pritika, Akshara, Subir. Okay. Electrolysis of aqueous solution. This is previous question. Previous J means neat. With fusion, no problem. You will get the direct. Yeah. Electrolysis of aqueous solution. This is important. Model next model question. Conductance is damn sure. Means probable. Previously repeated questions. Next electrolysis question. Right. Electrolysis of aqueous. Fusion is easy. You won't get fusion. Aqueous salts will get. Electrolysis of aqueous salts. First example. Electrolysis of aqueous CuS4. Aqueous copper sulfate solution. First of all, write all the ions. In aqueous copper solution, what ions are present? Which ions are present? First, let us write anions. How CuSO4 dissociates? CuSO4 dissociates into Cu plus 2 and SO4 minus 2. See here. Cu plus 2 plus SO4. Write anion. And water dissociates into how water dissociates? H plus and OH minus. See, at anode always write anion. See the procedure. First of all, we should write anions at anode, cations at cathode. Anion, so see pronunciation, anion, anode. This is anode, sorry. So let us write directly instead of writing anion, anode. Without writing water anions, water cations, let us write directly. At anode, take anions. What are anions? SO4 minus 2, comma, OH minus. Cathode. At cathode, cations. U positive and let's see this diagram. Every time you no need to draw complete structure, just write two electrodes and give the signs to them. And imagine battery. You have to imagine the battery because this is electrolytic cell. We are sending the current. Remember that point. We are passing the current, so you have to imagine the battery. But every time it is time waste, so write just electrodes and put signs for them. In this solution, these ions are present. All these ions. SO4 minus 2 OH minus. Next, Cu plus 2 and H plus. See, in the fused or molten, we have only one cation, one anion. There is no ambiguity, right? One cation is present that will go towards the cathode. One anion is present that will go towards the anode. But here we have two anions. SO4 minus 2, OH minus. Which anion will move towards anode? That is the question. We have two cations. Which cation will move towards cathode? See, if H plus cation moves towards the cathode, we will get a hydrogen gas. If Cu plus 2 moves towards cathode, we will get copper metal. Copper metal is repulsed. Products are changing, right? Similarly, if OH minus reaches anode, we will get a oxygen. SO4 minus 2 moves, we will get sulfur trioxide like that. Different products formation. takes place. So on what basis ions will move in this case? According to discharge potential theory, ions will move towards their respective electrodes. For example, take cations first. The cation which is having low discharge potential will move first towards cathode. The cation with low discharge potential. What is the meaning of low discharge potential? See, one new term to you, discharge potential. Discharge potential. I am giving one general word to you. Discharging means, in general, discharging means moving, displacing. Discharge means potential, energy. To understand that word, I am giving general explanation. Energy required to move. Energy required to move. Discharge potential. Here copper plus is present. To move towards this cathode, it needs some energy. SO4 minus 2 ion is present here. To move towards this, it needs some energy. Here also, copper needs some energy to move towards cathode. That energy is called as discharge potential. Energy required to move or displace towards respective electrode, On what basis cations and anions will move towards their respective electrode? Based on discharge potential. See, the cation with low discharge potential or anion with low discharge potential will move first towards its respective electrode. You should remember the order, discharge potential order. One simple example I'll tell you. Again, say one fat person is there. His stomach is some 10 liters. Okay, imagine, okay. One thin person is there. His stomach is only half liter. Right. Both are ready to move, but both are very hungry. Both are having zero energy. Fat person body is fat, big. He needs more energy, right? He has to eat more food, right? He needs more energy or not, fat person. So after eating so much food, he will move because he needs much energy to move. Are you getting the point? In case of thin person needs less food. He needs less energy to move, so he moves fast. Are you getting? The person who requires more energy to move, moves slowly. The person which requires less energy to move, moves fastly. Thin person requires less energy because he no need to carry his body. Fat person requires more energy because he has to lift his hand or leg. Correct? The cation with less discharge potential, the cation which requires less energy to move, moves fast. The cation which requires less energy to move, moves fast. Very simple. Similarly, the anion which requires less energy to move, moves fast. So let us write discharge potential for cation and discharge potential for anion. Then based on that we will write the product. Okay. What is the final conclusion? The cation with less discharge potential or low discharge potential will move first towards respective electrode. In case of copper plus 2 and H plus, copper plus 2 requires less energy for the movement. So discharge potential is less. So first copper plus 2 will move. So copper will be deposited. If we remember the discharge potential order, then we can write the product. So discharge potential for cation. Discharge potential for cation. So discharge potential order. This is discharge potential for cation and discharge potential order. Second year students, which ion will come first? Lithium, potassium, sodium, calcium, magnesium, aluminum, manganese, zinc, chromium, plus 3 or plus 2, iron, H positive, copper plus 2, Kg plus, Hg plus 2, platinum plus 2, and gold plus. Once observe these values, lithium and gold, which is having more discharge potential, this is decreasing order, right? Lithium is having more discharge potential. Gold is having less discharge potential. Practice 2 or 3 times. I'll give you one small hint to remember. So, which is having more movement here? Tell me. What is the statement? The cation with low discharge potential moves first. Similarly, the anion with low discharge potential moves first. This is discharge potential for cation. Among all, gold ions are having less discharge potential compared to the remaining. So they move fast towards their respective electrode, means cathode. Which moves slowly? Lithium. Why? Its discharge potential is more. Discharge potential is more. If you wanted to write, you can write another also. The order of movement, just write the reverse. Means this is greater than, less than. The order of movement towards electrodes. Reverse it. Or you remember like this. The cation with more discharge potential moves later. The cation with less discharge potential moves first. Discharge potential for anions. Online students are getting, online students. Hello. Discharge potential for anions. Anions list is small compared to cations. Anions are very easy to remember. F minus, PO4 minus 3, SO4 minus 2, NO3 minus, OH minus, this is for anion. Too much bright. Okay, okay. See, this question completely based on your memory. If you remember this, then you can answer. Otherwise, it is difficult. Okay. Electrolysis questions are completely based on discharge potential. But first time you will get some confusion. You will forget. That is natural only. Read a number of times, 3 times, 4 times. First, lithium, potassium, all these are alkali metals. First, remember, we write alkali metal. After that, alkaline metals. Like lithium, potassium, sodium. These are alkali metals. Next, alkaline metals. Next, P block, third A group. 1A, 2A, third A. Aluminum belongs to which group? Third A. 1A, 2A, third A. Next, D block. Remember like that, D block. And fixed zinc and iron. Fixed zinc and iron. Before zinc, manganese will come. Before iron, chromium will come. What we have to fix? Zinc and iron. Because we know zinc and iron. Before zinc, manganese. Before iron, remember that. Here alkali metals, lithium, potassium, sodium, calcium, magnesium, aluminum. Right. After H plus, copper. Copper will come after H. Remember, copper will come after H plus. Gold is last. This is direct. Easy only you can remember. F minus CO4 minus 3 sulfate ion, nitrate ion, hydroxide, chlorine, bromine, iodine. Okay, right. What is your question? Aqueous, copper, sulfate. We are doing electrolysis of aqueous, copper, sulfate. Our first question is electrolysis of aqueous, copper, sulfate. Aqueous. So more number of cations and anions are present. At anode, what I said to you, what we have to do? At anode, what we have to do? Anions. What are anions in aqueous copper sulfate? SO4 minus 2 and OH minus. OH minus will come from water. See the anions listed discharge potential, which is having more discharge potential. SO4 minus 2 is having more discharge potential, so its movement is less. Opposite. The one with less discharge potential will move fast, which is having low discharge potential. OH minus is having low discharge potential. Okay, so OH minus undergoes oxidation, and you know, all of you, for OH minus we have to remember one equation. 2H2O plus O2 plus 4 electrons by heart this equation. All. What happens when OH minus undergoes oxidation? By heart this, and remaining are easy only. Accidentally I given tough example first. Okay, aqueous copper sulfate. By heart this equation. OH minus upon oxidation will give O2. O2 gas. O2 is liberated, and along with the how many electrons are liberating? How many electrons are liberating? That is very, very important. 4 electrons. So by heart everything is here. 2 moles water is releasing. O2 gas is liberating, and 4 electrons are generating by heart. You will get no problem. If you do 1 or 2 examples, then you will get. At anode, reaction is over. O2 gas is liberated. At cathode. At cathode. At cathode. Right? Cations. What are cations in this? Cu plus 2, H plus. Look at this. Which is having low dp? Online students, tell me. Between Cu plus 2 and H plus, which is having low discharge potential? Online students. Cu plus 2 is having low discharge potential, right? So Cu plus 2 preferentially undergo reduction. Cu plus 2 will get 2 electrons and get reduced. So copper metal is deposited at a cathode. There is no logic in the question. This is completely based on the memory only. First write all the anions. At anode write anion. At cathode write a cation. Go to discharge potential order. Select the ion with low discharge potential and oxidize or reduce it. See? Can I give one example to you? You try this question. Electrolysis of aqueous AgO3 silver nitrate solution. Pranavi, are you getting light there? Say the answers online, students. What is the answer, online, students? Order is here only. Okay. Oxygenate anode. First anode. At anode, write all the anions. What are the anions in this? AgNO3 dissociates into Ag plus and NO3 minus. So NO3 minus and aqueous water. Water dissociates into H plus and OH minus. OH minus. So we have two anions. Now ambiguity arises. Then go to discharge potential order. What is the statement? The anion with the low discharge potential moves towards their respective electrode. OH minus is having low discharge potential, so it moves first. And we know what happens when OH minus undergo oxidation. We have to remember this equation plus O2 plus the O electron. If you feel any difficulty, at least remember O2 is liberated when OH minus undergo oxidation. At least this statement. When OH minus undergoes oxidation, O2 is liberated and 4 electrons are liberated. Remember this by heart. When OH minus undergo oxidation, O2 is liberated and 4 electrons generated. Cathode. Write all the cations in the aqueous AgNO3, Ag plus and H plus. Which is having low discharge potential. Ag plus is having, see H plus having more discharge potential. Ag plus having low discharge potential. So select the cation with low discharge potential and reduce it. So silver is deposited. Silver is deposited. These are the model questions. Which of the following statement is true? O2 is liberated during the electrolysis of aqueous copper sulfate solution at anode. Hydrogen gas is liberated. Different statements you will get. You have to select the correct one. Give light, light, light. Next, next question. Aqueous NaCl. Aqueous NaCl. This third example, I think, right? First, aqueous CuSO4 is given, AgNO3 next. Third example. Make it fast. I'll have to complete it. Online students answer. H plus will liberate. At anode, what is the product? You know its name, write another name also, brine solution. Aqueous NaCl also called as brine solution. Brine solution. Others, please respond. Only few. Ketra only responding. Alfia, Aisha. Zubair respond. Second is Roshana, Pragnika. Akshara. Akshara, are you following Akshara? Hmm. Hmm. At anode, write anions. Anode, anion. Anode, anion. Cl minus from NaCl, OH minus from water. OH minus from water. We have two anions. Now ambiguity. Which anion will move towards anode and which anion undergoes oxidation? That is the question. Ambiguity. Go to discharge potential order. Between these two, Cl minus and OH minus, which is having low dP, Cl minus. Cl minus. So Cl minus preferentially undergoes oxidation. Oxidation means loss of electron. Cl electron. To balance the equation, take two chlorines, Cl2 gas and two electrons. Or you can write half Cl2 also. So Cl2 is liberated at a anode during the electrolysis of aqueous sodium chloride solution or brine solution. Cathode. Na plus is cathode. Sorry, cation. H plus is cation. So between these two, which is having low dP? H plus. Sodium plus discharge potential is more. H plus discharge potential is less. So H plus preferentially get reduced. Reduction means addition of electrons. H. H but single hydrogen do not. You can take 2H plus 2 electrons. Or you can write half H2 also. No need to take 2 here. Instead of taking 2, you write half H2. So hydrogen gas is liberated. This is important question. We kept in dark mode. Eye protection. Normal. Hmm. Now. Hmm. Right. We follow this discharge potential when we use inert electrode. We completed one model question, right? We did one procedure, writing products at cathode and anode. And this total procedure is applicable when we have inert electrode in the electrolytic cell. What is the meaning for this? When inert electrodes are present in the electrolytic cell, then only follow the procedure to write the product. When active electrode is present, then what we will do? Clear? This discharge potential order, this cation order, anion order is applicable when the electrode is inert only. They will mention the electrode name. Based on the electrode name, we follow the procedure. If active electrode is given, then another procedure slight different from the top. Slight difference. Okay. Let us see. One note, important note. The above discharge potential order is applicable. The above discharge potential order is applicable. In case of inert electrode only, in case of inert electrode only. When inert electrodes are given, follow the previous procedure, means writing the anions at anode, writing cations at cathode, and observing which is having low discharge potential and selecting that procedure. If active electrode is given, then what we have to do? Before that, you tell me in electrodes concept I explained. What is inert electrode? What is active electrode? For someone or something. Sure. Once liquid. This is electrolytic solution or electrolyte. This is electrolytic solution or electrolyte. I am placing one electrode, let us say zinc, and in another electrolytic solution I am placing graphite. Right. This is a metal electrode, this is non-metal electrode. Okay, final electrode. When you place the electrode in electrolytic solution, if this electrode reacts with this solution, electrolytic solution, here liquid is there, liquid is there. If this electrode reacts with this electrolytic solution, this is called as active electrode. I already given active electrode. Active electrode means simple definition, the electrode which reacts with electrolytic solution. Active electrode. I given the code also. What is the code? If the electrode do not react with the electrolytic solution when it is placed in the electrolyte solution, it is called as inert electrode. Inert electrode. Graphite, platinum are the inert electrode. Carbon, even carbon and graphite both are same. Right. Examples for active electrodes: zinc, copper, and silver. I given the codes also. Are you getting idea? Zinc or sil code, zinc, copper, silver. Remember, this is the code to remember active electrodes: zinc, copper, silver. Inert electrodes: graphite, platinum. We did one procedure before that is applicable when platinum or graphite electrodes are given to you. In the question they will mention. Generally, moderate level question only will come. What is the product at anode? What is the product at cathode? These type of questions will come. And next level question is by mentioning particular electrode. See, what are the products at cathode and anode during electrolysis of aqueous copper sulfate? Is the last ending using platinum electrode. Using zinc electrode, then answer will change. So you have to observe the question completely. Whether active is given or inert is given at the end of the question, that is important. When inert electrode is given, follow the same procedure. Right. When active electrode is given, then how to write the product. Clear? Now let us start electrolysis with the active electrode. This is very easy compared to that. Electrolysis of aqueous solutions when active electrode is given. Electrolysis of aqueous solution when active electrode is given. See, at cathode, follow the same procedure. Follow the same procedure. In case of, as in the case of inert electrode, means first we followed one procedure. based on the discharge potential level. At cathode, same procedure, no change will be observed at the cathode. At anode only, the procedure will change. See, with active electrode and inactive electrode, procedure is same up to cathode. Up to cathode. In case of inactive electrode, what we will do? We write cations at cathode, we write anions at anode. We will select the anion or cation with low discharge potential, and that will move towards respective electrode. In case of active electrode also, at cathode, follow the same procedure. Just change the procedure at the anode. At anode, what happens? Let us see. If we do one example, then we can understand. First of all, write the procedure at anode. See the procedure. Select active electrode given to you. Select active electrode given to you and oxidize it. I'll explain by taking one example clearly. First of all, you should understand what we will do in case of active electrodes. At cathode, procedure is same. Writing cations and selecting the cation with low discharge potential. At anode, don't do anything. Just select active electrode. Active electrode is given in the question. They'll mention active electrode name. Oxidize it. For example, M is the active electrode. Oxidize it. M plus electron. What is M? What are active electrodes? Zinc, copper, silver. These three will come, and this is the common reaction at anode. You don't need to remember anything. Just zinc Zn plus 2, copper Cu plus 2, that reaction. Silver Ag plus. Active electrode is mentioned. They mentioned. No, don't write anything. See this question, you will understand. After discussing one question, you will get. You write the question. What are the products at cathode and anode during electrolysis of aqueous copper sulfate solution by using see they are mentioning active electrode name by using copper electrode. Active electrode name is mentioned or not? What is active electrode name? Copper. Copper is mentioned. Remember this point. At anode, what we will do? Which electrode is name mentioned in the question? Take that electrode and oxidize it. Means remove electrons from it. At anode. Very simple. First read the question. They will give question. What are the products at cathode and anode during the electrolysis of aqueous copper sulfate solution using copper electrode? Take that copper and remove electrons from it. If they mention same data, if they mention using zinc electrode, take that zinc and remove electrons from it. That is only the reaction at the anode. First of all, write at cathode. At cathode, what are the cations in this aqueous copper sulfate? What are cations? Cu plus 2, H plus. Here procedure is same. At cathode, procedure is same. Which is having low dP? Cu plus 2. Plus 2 electrons gives rise to Cu. Same procedure we followed at the beginning, right? At anode, this is only problem. At anode, what I said in the question, they mentioned active electrode. What is active electrode? Copper. Take that copper and oxidize it. That is only the reaction. Reaction at anode. In the question, they will mention active electrode. Take that active electrode, remove electrons from it. That is only the reaction. Don't write anions, don't compare anything. If zinc is mentioned, zinc gives rise to Zn plus 2 electron. Online students, did you get this? Hello? Only Ketra only responding, no other, no other. Okay, right, we'll continue tomorrow.